With me on page 328.52. And let's start with verifying trig identities. First of all, look what it says right there, it's highlighted. To verify an identity, it says it means to prove that both sides of the equation are equal for all values of the variable for which both sides are defined. This is done by, here's your ways of doing it, transforming the expression on one side of the identity into the expression that basically matches the other side. Basically what they're saying there is you can leave one side the equal sign exactly the same as it is and just deal with the more complicated side, trying to simplify it, like we've been doing in this first section of this chapter. It says you can do that by a sequence of intermediate expressions that are each equivalent to the first. As with the other types of proofs, each step is justified by a reason, usually another verified trig identity or another algebraic operation, just like we talked about, factoring, substitution, changing it into sine and cosine, getting rid of the denominator, or getting a common denominator so you can combine the numerator as an option. It says you will find that it is often easier to start the verification of a trig identity by beginning on the side with the more complicated expression. Okay, we're good with that, right? And working toward the less complicated. In other words, you're not going to combine across the equal sign. Leave one exactly like it is, choose the more complicated side, verify that matches the one on the right. Good? All right, let's do one. Starting off, oh, I lost all my pens. Who's got my pens? Are they on my desk?
We have black and blue ones. The ones I'm looking for. They're the dark ones. I can't see the other ones.
All right, so let's start with example 1. Cosecant, somebody read it to me. Cosecant squared x
minus 1 over cosecant squared x equals cosecant, just kidding, cosine
squared x. Okay, first of all, which one's the complicated side?
the
Right side.
The left side, right? Or if you're looking this way, this side. So let's leave this one exactly like it is, and let's work with this guy to try to get it to something that is going to be just like that one. Okay? Easy enough, right? First thing you want to do is what? Do we know anything about this? I thought I saw something over here. Yep, cosecant squared theta is equal to 1 plus cotangent squared theta. Well, we can move the 1 over here, move the 1 over. We get cosecant squared theta minus 1 is equal to cotangent squared x. I'm going to leave this just like that for now. Okay, let's substitute now into what? I gave you a hint.
Substitute.
Yeah, let's substitute.
Cosecant 1 cosecant squared x is the same as sine squared.
Okay, this is over 1 over sine squared, right? Let's try it again. Well, here this is cosine. I'm gonna caution you a little bit about the squared part, right? Because there's not anywhere that says that cosine x over sine x that you can square it, and it's exactly that. We could look at that, and we'll make a judgment call for that one. Let's look at it in the book first. They come up with this sine squared. This one will be easier. This one I'm going to leave for right now, okay? So I'm going to put this over. Oh, I was writing it correctly. I got sidetracked in my mind. 1 over sine squared x. This one, no problem. So this will become, we multiply by the reciprocal, comes up on top, that becomes cotangent squared x times sine squared x. Good? Okay, now what can we do?
Cotangent squared x.
Now we can make this into squares, right? So this is cosecant squared x over sine squared x times sine squared x. You'll see that these two are going to cancel each other. What do we have left?
cosine squared
Does it match?
x
what we left behind. Easy? So your goal here is to substitute, factor, whatever you need to do to make it verify that the other side is equivalent. Okay?
Miss Betty,
Yes.
if it has that weird thing, the weird sign, like in, could we just, like in the homework, could we just write an X instead of like the theta or the A or K?
Oh, the alpha, the little fish looking thing? Yeah, you can change to a variable name if you need to. If that symbol bothers you, that makes you thought there's something else going on here, yes, you can change it to a variable, that's fine. All right, keep going. Underneath example 1, it says there are usually more than one way to verify an identity. We've talked about a couple here in this one. For example, in the identity example 1, you can also be verified as the following. Look what they did there. They took this, let's do it over here. Cosecant squared x minus 1 over cosecant squared x. Okay, what did they do first? They split this bottom right, the monomial, into two correct? They split this underneath this part and this underneath that part. Then this becomes what? 1. What is this? 1 over cosecant squared x. Say it with confidence.
Sine squared.
It is sine squared, right? What does this equal? 1 minus sine squared x?
Cosine squared x.
Cosine squared x. And now you have verified it a second way. So there's not always one way. Sometimes there is just one way, but this one actually gives you the option of 2 different ways to verify this one. All right, top page 321, it says when there are multiple fractions with different denominators in the expression, you can find a what? We've already done this in section 5.1. Common denominator. To reduce the expression, instead of having 2 different fractions, now you have 1 fraction. With the common denominator, you can combine some factors on top or behind, like combine some terms on top. Okay. All right, let's see. Example 2. It says verify that 2 cosecant x is equal to 1 over, oh goodness, look at all these terms. Anybody else thinking that? The good thing is these are what of each other? What are those? Starts with a con, ends with a conjugate.
Conjugate.
Thank you. They're conjugates of each other. So that makes it kind of nice. That might come into something that you can do. But that's okay. We're going to leave this side, and we're going to work with this side since it's got 2 fractions. Okay, let's make it into 1 fraction. What's going to be our denominator? This times
Cosecant squared
I'm going to write this for this moment because I want to put this on top. So over here we need what? Cosecant x minus cotangent x. And then plus, what goes over here? Oops, cosecant x plus cotangent x. Get the idea? If I combine it into 1 fraction, got a common denominator. Let's see what we can do to simplify it. At the top, we got cosecant plus cosecant gives me what? 2. There, good, you're paying attention. Minus cotangent x plus cotangent x gives me 0, so I've gotten rid of that. What happens on the bottom?
foil.
FOIL. Cosecant x squared right? This times this is that square. This times this. Oh, I missed a minus sign somewhere, didn't I? Thank you. Feel better, right? Okay. So the middle two terms will cancel, good. And then we'll get,
Minus cotangent.
okay, do we know anything about this term?
It'll equal 1.
It does. Pythagorean theorem says 1 plus cotangent squared equals cosecant squared. We move over the cotangent. The other side, this equals 1. We are left with, I'll just pull this down here. How's that? So we see that it does match exactly. Okay?
Will they all match?
Yes. When they're asking you, when the instructions say, I verify the identity, your first clue is, ooh, I probably need to figure out how to leave one side exactly what it is, and bring the other side down to that level. Okay, so start there. Make sure you read the instructions to ask to see what they're asking you to do. Because what were the instructions in 5.1?
Simplify.
Simplify or rewrite to eliminate. Simplify, use co-function in odd, use Pythagorean, use reciprocal. So they tell you exactly what they want you to do with it. And in this case, verifying. Okay? So example 2. Look above example 3. It says, to eliminate a fraction in which the denominator is of the form 1 plus or minus u or u plus or minus 1. Remember to multiply the numerator and the denominator by the conjugate. Now the denominator, didn't we just do that? No, we didn't eliminate it. Then you can potentially apply a Pythagorean identity. So let's try this one. Everybody done with this one? Done looking at this one? Okay. All right, example 3. It says verify that the sine of x, I change the alpha to x, over 1 minus cosine of x is equal to cosecant of x plus cotangent of x. Well, this one's kind of a giveaway because they've got, even though both sides, neither side looks really easy or simple, they're teaching you how to do what? Deal with the conjugates, right? And what they said do here, they said to get rid of, how was the words they used? To eliminate a fraction in which the denominator is of the form 1 plus or minus u. U being some kind of function, right? Trig function. So obviously they tell you to multiply the top and the bottom by the conjugate of what's on the bottom. So that means we're going to 1 plus cosine of x, 1 plus cosine of x, top and bottom. Here, do it this way, that'd be easier. Okay, on the bottom we're going to get 1 times 1 is 1. Ooh, here, let's move this down a bit. 1. 1 times minus cosine plus cosine will eliminate, middle terms will eliminate because of the conjugates. And then cosine times minus cosine is, oops, forgot the s, hang on. Mary started something today, keeps dropping some things here. And we'll put the sine of x, oh, I guess I can distribute the sine of x, we get sine on the top, sine of x, plus sine of x, cosine of x. And we're still trying to get to equal what's up there. What do we know about this? 1 minus cosine squared of x.
Sine squared.
It is sine squared of x. Okay. Oh, maybe I should take that back out. I'll take it back out. 1 plus cosine of x. I can see I'm going to eliminate at least 1. Right? So this is going to now give me 1 plus cosine of x over sine. Get rid of that. Which means I'm going to get 1 over sine of x plus cosine over sine of x. Okay, what does that equal? What is sine of x? Cosecant. What is cosine over sine? Does it match? It matches. We made it. When you rewrite it, you've done it. Verify the identity. So giving you techniques that you can work through and try. So when you're given the problems without them being broken out into examples like this, you need to remember to think through these. Okay? Look on the left-hand side, it says a little study tip, an alternate method. It says you do not always have to start with the more complicated side of the equation. Oh, I thought Miss Patty just said I had to. Look what the if says. If you start with the right-hand side of example 3, you can still prove the identity. Remember how I asked you which one's the complicated side in this one? I said, oh, well, they told us what we're doing in this, so I knew I was going to choose the fraction side. But they're saying you can start with this side at any time and work your way back, because these are kind of equally complicated based on what they are. All right, the bottom of the page, 321. Until an identity has been verified, you cannot assume that both sides of the equation are equal. Therefore, you cannot use the properties of equality to perform algebraic operations on each side of an identity, such as adding the same quantity to each side of the equation. Did you get that? Let me say it again. There's an equal sign there, but they're telling you to they're telling you to verify the identity. So that even though the equal sign is there, it doesn't mean that you can do the algebraic operations we're used to and add to both sides, multiply to both sides, any of that. Because they want you to verify exactly what's there. So don't fall in the trap of adding, oh, I'm going to add cosine to both sides, or I'm going to multiply by cosine on both sides, right? You've not been given permission to do that when the instructions say verify. It says when the more, turn the page, 322. When the more complicated expression in identity involves powers, try factoring. Okay, so another technique. Try factoring. Okay, example, where are we at? Example 4. Verify cotangent x, secant x, and cosecant squared x minus, what I got? Cotangent cubed, secant, and equals cosecant. Equals, finally an equal sign. Cosecant x. Okay, which one's the simple sign? Just curious if you know. The right side, all right? It seems obvious. Okay, let's look at this one. What do we got going on here? We got a cosecant squared, cotangent, okay. So here we look and we say, first thing, start on the left-hand side of the identity. They just identified what the complicated side was. Second line says factor. What do we have we can factor out? Well, we have secant in both, and we have cotangent in both. So let's factor out that. Cotangent x, secant x. What's left? Here, those are gone. We have cosecant squared x minus cotangent squared x, right? Woo, that was done. Okay, here's what I want you to try. We're not quite done with section 5.2, first part. So we've gone through, we're not finished with example 4, so examples 1, 2, and 3. So 1 through 17 odd will be your homework tonight. Try those. We will discuss it tomorrow, and we'll start exactly on example 4, okay? And we'll try not for me, thanks.